Okay. Those of you who got a less than ideal score for exam 1, it's okay. Calm your existential nightmare. You get to retake any exam at the end of this course, so don't worry about it. One thing I did notice is that only like 2 of you managed to use ggSave for saving your plots, even though a lot of you use ggplot. So I tried to leave comments on your exams on Canvas, but typically a much better idea to use ggSave than to use PNG and devoff if you've made a ggplot, because it gives you a lot more control. You get higher resolution. You can set how wide and long your figure is, all that good stuff. And best of all, it's easier. It's one little line, ggSave. Okay. So yes, to update you on the ugly plots, Twitter is blowing up right now. People voting on which plot is the worst. I was really impressed with how crappy your plots were. Really, really impressed with it. Best of all, though, we got a retweet from Hadley Wickham, the author of ggplot. So the guy who designed ggplot, who has like 45,000 followers, sent this out there. So people are voting like mad, and everybody, the entire RSATS community is seeing how bad you are at making plots. It's amazing. So I will hopefully have results for you by the end of the day, maybe tomorrow or so, see who gets the super special prize. In the meantime, let's go ahead and take a look at those. I'll share my screen. So these are just the ones that were turned in on time. Wait, contest entries. All right. So if you haven't seen these yet, all right. What data set was this?
Bueller.
Steven.
All right, that was empty cars.
Empty cars. Well, you wouldn't know, would you? What I love about this, besides the very disturbing picture, is the fact that you managed to get like a line plot and a violin plot on the same axis, which doesn't make any sense. That had to take some doing. Okay. Do you want to share? Dalton's not in with us yet. Okay. I have no idea how he did this. I was hoping he could share. All right. Alex, tell us about what we're seeing.
This is the plot that I made. As you can see, I correctly labeled all of the axes with yes and no. The plot set was Iris, and
that's Iris?
That's Iris, yeah.
Okay.
I believe I deleted my code because I want it to remain a national secret and so that nobody can duplicate this. But I believe it was pedal width versus like pedal length or something like that.
Okay.
And then I searched ugly anime guy, and that was the first result. So I threw that on the background and just.
So is this a geom point and then a geom line?
Yes.
On top? Okay.
Yeah, and then just tried to just mess with everything and make it look as painful as possible. So.
Yeah, I hate it. Thank you.
Good to hear.
All right. Trevor?
That's Iris dataset. The background came from your website, Dr. Zahn.
Yeah, I see that.
And mushrooms plotted on the Iris dataset. So
excellent. Emily?
So I made my own data set of days until Christmas. And since all your articles are like, oh, don't ever use pie charts, I decided to use a donut chart in the complete inappropriate way.
Did you have to use like coord polar?
No, I think I should use something else.
Okay.
Let me see. I can pull it up. I kept mine. I guess I don't want it to be a national secret. Let's see.
Because it's really bad.
Yep. That's what I was aiming for. I wanted it to make no sense. Oops. Oh, maybe I didn't save it.
You should save these for posterity. I mean, this.
There,
I wouldn't know how to make this. I would start. There's a coord polar option.
Oh wait, okay, here it is. Let's see.
Okay.
I used, so I did use coord polar. Yeah, so it was coord polar. Geom rect, and then I did theta equals y.
Okay. Yeah, so coord polar can be. It actually does have some real uses. Like if you're showing cardinal direction or something like that, it's a way to basically turn your data into angles on a circle. But you've used it for evil here. All right. Carlos. This Star Wars, I presume?
Yep. So yeah, just pretty straightforward data set and all that. Just simply made sure it was all gray to make it all blend in and like look kind of gross, and then I did a chord flip.
You also, and I'm not sure how.
Yeah.
If you look closely, there's like a white bar that covers some of the pictures.
Yeah.
Sometimes.
Mm-hmm. Yeah, I ran the Geom smooth on it, just to make it ugly.
Yeah. Okay. I have no idea. But yeah, there is a white bar across some of them and not others.
I actually only noticed the one on the right. I did not notice all the other ones.
Yeah, it's almost like you did a width of one bar on top of Jar Jar, which is the worst. Okay. Ernie.
Hello. Yeah, so I also use the Star Wars plot. And I I did a background picture and then a picture for all the.
What is the x-axis on this?
What's the x-axis? I think it's the height. Wait, the height. 1 second.
Oh, okay, I see. So it's height by character. All right. Well, you've all disappointed me very much. I'm so proud of you. So good work.
Dude,
well, your ggplot skills are growing. They are on the dark side of the force, obviously, but hopefully there's still good in you, Father, and you can change. So let's move on to messing with our data some more. All right, so now that we can plot it. All right, so I'm in my data course R project, so go ahead and get into yours. Start a brand new script with Control or Command Shift N. And then we're going to start out today working on the MLO metadata.csv file. So get your digital hand raised up when you've got this opened and have read in the MLO data. This second package I've got loaded really only comes with a couple useful functions. You don't need to do it if you don't want to, but if you want to, go ahead and do install and then skimmer. It gives us this little skimming function which lets us kind of view our data just like glimpse or just like clicking over here on the right. Okay, but it prints it out for us and it does a couple, I think, pretty useful things. It gives you an overall glimpse of your data, the name of the data frame, the number of rows and columns, and then it tells you how many of the different types of columns you've got. So in here it's saying you've got 5 character and 9 numeric, and then it groups them based on their types. And so it says, all right, here's your character vectors, sample ID, here's the number missing, that's really handy, I think. The completion rate, so we got 100%, that's on a 0 to 1 scale. Min and max, the number of empty, the number of unique, and then those with white space in them. Very useful. So if you're having trouble with your data and it's not cleaning up right, maybe doing a little skim to see if there's white space in there is kind of a nice little go-to thing. Maybe it's just that you've got spaces after things that are coming up weird. Okay, and then it says, here's your numeric, and it gives you the mean, standard deviation, some nice stats, like summary stats on it, and then kind of just for fun, it gives you a little histogram for that variable. If I make this a bit smaller, it should all show up on the same line. It might be easier to see. Yeah. So we've got a variable called day. There aren't any missing values, and here's a histogram of day. So it comes in handy. All right, still a few more of you haven't gotten this loaded up yet. So Dalton and Lacey, do you need help with anything?
I'm just trying to, is this .csv, is it in the code examples?
It's in data.
Oh, it's in date. Oh, yeah.
Yeah,
okay.
So if you're in data course Bowen, it should be in data MLO metadata.
Okay, mine's just saying no such file directory, so I'm assuming I'm in the wrong spot.
So that means, so in my data course Zon, if I do ls or look around, I have data. Do you have that in yours?
Right.
If not, you'll need to copy it over from the main data course. Just copy the whole folder in.
Okay, great.
All right.
So I'd like you first.
So I installed the skimmer,
Uh-huh.
and it's still giving me an error for skim.
For skim?
Yeah.
When you did library skimmer, what did it tell you?
Just library skimmer.
Mhm.
That's it. It just showed that
That's
up at the
nothing?
bottom.
Okay.
Yeah.
You want it to say nothing, and then you definitely called your.
Okay, I just forgot to run the library after I installed.
Okay. So Glimpse comes with tidyverse, and it's just a quick look at your data set just to start getting a feel for it, right? The first thing we do is once we manage to get it loaded, we kind of want to get a feel for it, okay? Skim is just another way. Sometimes I find it handy, especially for like seeing how many entries have white space in them, or looking for the number missing, right? Kind of just another useful tool. So now we're going to learn our dplyr verbs. Let me show you another little trick here while we're at it. If I put 4 little hashtags at the end of any comment line, it gives me this little arrow right there, which lets me collapse that entire section of code to keep things tidy. And if you click up here in the top right, document outline, show document outline, it puts everything with 4 hashtags over here so you can like move around in your code. That can be kind of handy, especially if your code's getting to be like 100, 200 lines long, breaking it up into sections. So I'm going to start doing that from time to time here. Okay. And really, it's handy if you've got a section of code you know is working right, you can just collapse it so it's easier to kind of see what's going on. Okay. So dplyr verbs.
Can I ask one question before we get started real quick?
Yes.
So why do we work in projects again? Because I noticed that it doesn't like save the scripts or anything. It does save a history, it seems, but there doesn't seem to be much reason to do it as far as I can tell.
We work in projects specifically so that we can use relative file paths. Right, so if we weren't in a project, I would have to give my computer complete directions from the root to how to get to this file, which would be different than on your computer. All
right, thank you. I understand now.
Yeah, that's really that's the benefit of using projects. It lets us package our data, our code, and our output all in one little folder, and it's going to work on anybody's computer.
Okay, I'm sorry. I still can't get this working. Can I just share my screen super quick and see if you can help me out with that? Okay. Okay, can you see it there?
Yeah.
Okay.
Cannot open file, no such file or directory. Okay. You're not in a project.
Okay. So
very top right of your screen where it says data with the little arrow next to it, click on that. Go down to data course Bowen. Click on there.
Just cannot see those. Okay.
All right, now Control Shift N or Command Shift N for Mac. Okay, so now you should be able to do library tidyverse and read it in.
Okay.
So yeah, this illustrates exactly why we work with projects. Now that you're in that project, it knows that there's a folder called data. It didn't know that before.
Okay, I wonder if I might. So this, like over here where the Git is supposed to be, is now gone. So I wonder if I have something set up incorrectly then.
Oh, right. Okay, just go to your file open. Because remember you had 2 data course colons?
Yep.
Yeah, go to file open.
Down here.
And then go to your desktop, data course Bowen, and then dataCourseBowen.rproj.
CourseBowen.rproj, and that should be. Is that in the?
It'll be in your desktop under dataCourseBowen, and then inside of dataCourseBowen folder will be dataCourseBowen.rproj.
Okay, I don't have that actually, so maybe that's the issue.
Yeah.
Okay.
For now, stay where you are.
Okay, and then I'll work with that.
We just won't have Git. We can stay after and fix it for you.
Okay, thank you.
Yeah.
So if I just do all of that now, it should work. Should I just do it
Yes.
super quick to make sure? Okay.
Then read CSV.
That's right. Oh, do you assign that to data frame though first?
Yeah.
Okay.
In quotes, yeah.
Okay, and then
So now start typing data in all caps. Hit tab. What? Okay. Delete, delete. Go back to data and hit a data, then another slash. Now hit tab. Nothing. So you don't have data in your dataCourseBowen. Let me share my screen with you.
Yeah, because when I pull it up in my Finder, it's there.
It is?
Yeah. I'll try to pull up.
All right. Go ahead and stop sharing your screen so I can share mine.
All right.
Okay, so bring up my equivalent of Finder. Desktop, dataCourse Zon. So this is what you should see. You should see
right.
dataCourseBowen.rproj, data, code examples, assignments. Okay. What do you not have in there?
So I click on desktop, then I have dataCourseBowen, and then I guess it's the rproj that should be there.
You don't rproj?
Right. So it just goes straight to like data.
What you would do is file, new project. Okay. I'm not going to save this. I'm just going to copy it over here. Okay. So file, new project. Don't save. Existing directory. And tell it browse straight to desktop dataCourseBowen. And then just say create project and you'll be good.
Desktop dataCourseBowen, and then it would just open, I'm assuming
create
there.
Project, yep.
Okay.
So that should fix it for you. And then you should already be in that project at that point.
Okay. So I would just want to save this as dataCourseBowen rproj, or it probably will save it on its own like that, right?
Yeah, and it should show it up in your top right already. dataCourseBowen. Like
yep.
That.
Okay.
Okay. Should be good.
Great. Thank you. Sorry.
No worries. All right. So let's see. Yeah. So here we're working, I wanted you to read the tidy data chapter and the transforming data frames, and then dplyr verbs and tidy R verbs. We're going to start out today talking about these dplyr verbs. Okay. And these are the main ones, and we'll have another. So total of 6 that we're going to cover today. Mutate, select, filter. You've already seen filter. summarize, arrange, and group by. Okay. So keep this handy. Another nice thing is the link to the cheat sheet. I've got one of these printed out that I keep next to my computer at work. It's just got everything you need right there. All right. So let's take a look at what these do. Who can tell me what filter does, since we've already used that?
Sure. So it selects specific rows based on whatever parameters you set.
Okay, so it's for selecting rows based on some criteria. So that's filter. Okay. We've also got select. What's that do? It picks columns. All right, so filter picks rows, select picks columns, arrange. Anyone want to take a wild guess?
I'll bet it arranges your data.
It does, based on a column. So it's kind of like a sorting function. Okay. So we've got, oh, where were we? Filter, select, arrange. Then we've got mutate. What do you think mutate does?
It makes a new variable that is a function of another. I got to read that before it disappeared.
Cool, yeah. Create or modify columns as a function of existing columns. Okay. And then we've got group by. Create groups based on a column. And summarize. This can be spelled the American or the British way. They work exactly the same. Summarize, usually based on grouped variables. Okay. And there's one more thing. I mentioned this in our Teams channel, but it's that. What is that?
Pipe command.
Pipe. And what's it do? What did it do in the command line where it was that?
It sends the output of one command to the input of another.
Okay, in the command line, most of our commands just took one input. In R, we know that's not the case. There's all kinds of stuff that we can feed to each of these functions. So it's the output of left side becomes first argument of right side function. Okay. Let me demonstrate it. We've got df, right? That's our MLO data. If I wanted to look at it with glimpse, I would say glimpse df. And there it is. I could also say df, and there is a shortcut, Control-Shift-M. Control-Shift-M gives you a nice little pipe. df piped to glimpse. So on my screen, lines 25 and 26 are identical in terms of what they give you. Does that make sense?
What's the advantage of using one or the other?
Well, when you chain a bunch of commands together, it becomes a bit more clear. So let me see if I can find, there was a nice little pictorial. Well, that's useless. That's just a bunch of text. No, I'm going to have to do this on my own. Okay. The way that R usually works is it evaluates chained functions from the inside out, one step at a time. So take, for example, day, our first column here. So I could say df $day, all right, and it's just a bunch of numbers. If I wanted to add 5 to all of them, I would do it like that. And then what if I wanted the mean of all of those with 5 added to them? So we're working from the inside out here. First, we're adding 5 to day, and then we're taking the mean of that. Now, if I then wanted to round that to two digits, I would wrap that in round. Okay. So you see how this is working? We're constantly moving from the inside outward. That's harder to read than the following. df day pipe mean pipe round 2. Gives us the exact same answer, but here we can see how this is broken down into subsequent steps. So the advantage of the pipe becomes readability and writability. Okay.
Question.
Yes.
Would you need to put a comma before the 2 in the last round?
Nope. It implies the comma already. So it already knows that the first argument is the output of these 2 steps. So if I want to see what df day piped to mean is, I just highlight those parts without this last pipe and hit Control Enter. There it is, 2057.725. The whole thing, 207.57.73. So we've rounded it to 2 decimals. Okay. So that's what a pipe can get you. It makes your code nice and readable. It's easier for me to grade. It's easier for you to come back the next day and kind of see what was going on, because you can just do one line per command. And you know that it's chaining things together. Okay. So let's take a look at some of these and use the pipe for them. Okay. I'm going to put that in quotes so it's not freaking me out. All right. So we've got df. Control Shift M. We're going to pipe that to filter. And what do we want to filter? We've got day, sample ID, year, quarter, month, M day, Y day. We'll look at these again. So let's just do the months April and May. How would I do my filter so that we get just rows that have the month April or May? Any thoughts?
I can't remember how to say or, but you just say filter month double equal sign April in parentheses.
So we could do month double equals April, or it's the pipe.
Or is the pipe, okay.
Or month is equal to May. Maybe an easier way of writing that would be filter month is found in April, May. I'm going to do it the second way because you can imagine if you had like 15 different values, you wouldn't want to keep typing month is equal to May, or month is equal to February, or so this in is pretty useful. I'm gonna comment this out. Okay, so there, we filtered it. Just with that little step. I'm going to do another Control-Shift-M. And so this filtered stuff, then I can go selecting some columns. Which columns do I want to select? How about just the numeric ones? Oh, that didn't work. All right, what questions do you have about where I am with this command so far? I've chained three things together.
Where function?
The where function. That's also built into our dplyr. Okay. So it has to work within some of these commands though. So select where is numeric. Basically you give it a true false statement. Okay, so it could be starts with M. I think that would work. Oh no, skimmer brings us another one. So dplyr. So I could do is character.
What package is where a part of?
Where is part of dplyr. But it's not its own function. It only works within select right here.
Okay.
So I don't have to do that. I could give it the names of columns I wanted. So I could select concatenate month, and day. Does that make sense? I've given it a list, a little vector with month and day in it, and it's selected just those columns, and they do happen to just be the ones where month is April or May. All right. So here you can see you'll only find April and May, and there's only 79 more of them out of originally, like, how many? 382. Okay. So we could select that, or I could put a little minus sign right in front of the C. What do you think that's going to do?
That'd be everything that's not month and day.
Everything that's not. So that just inverts it. Okay. So this is filtering to just April and May rows, and then selecting everything except month and day. Okay.
So could you use the exclamation point instead of the minus sign?
Mm-mm. Nope. Works a bit different. You can use the exclamation point by saying, like, where not is numeric. So let me get back to that. So I could put an exclamation point right there and get everything that's not a character. Or maybe it's not right there. Select, where is character? Yeah, right there. So that would return everything that's not a character. Not where is character. All right, so I'm going to keep it as where is numeric. So the same as not where is character for this particular data set. So we've got April and May. We're picking all of the numeric columns, and hopefully this is a bit easier for you to read than the base R version, which would be DF, and then using this, right, where DF month equal to or is in concatenate April, May, and columns is, I don't even know if this would work. Yeah, we'd have to find the numeric columns first and then pass them in. Okay, that's harder for me to read. It's harder for, I think, most people to read because it's just a long, growing from the outside stretch of garbage. Whereas here, we've broken it up into steps. So we've got our pipe. We said, all right, we're starting with DF. Filter for where month is in April or May, and then select the numeric columns. Okay. Let's keep chaining to this pipe. Now we can arrange.
Quick answer.
Yes.
Where still isn't working on mine. I have all the right libraries loaded. I have it typed in like the same as you, but it's still not working. Like it just says could not find function where.
And you have tidyverse in?
Yes. Otherwise, the pipe
this pipe is right here?
Right. Yep.
It was doing that to me too because I didn't have the right number of parentheses. Like when I hit numeric, it would open another set of parentheses, and it didn't like that.
Yeah.
Yeah, I tried deleting that parentheses, and it still isn't working.
Share your screen with me.
Okay, sure. Are you seeing my screen?
No.
Or here we go. Maybe. Okay,
Yeah,
there we go.
something's coming up.
All right. So,
all right.
here.
Filter month in, concatenate April, May. Select. Where is numeric? I'm getting pretty low resolution. I can't read the line after
here.
your error. It says error could not find function where, and then it says something, and I can't read that.
Let's see. Can you see it now?
Scroll down in your console. I want to see the output, your error message. Yeah, I can't read what's after error could not find function where.
Oh, okay. It says run rlang : last error to see where the error occurred.
Yeah, go ahead and run that.
Just like that?
Mm-hmm. Okay, so here's the backtrace. Filter was fine. Tidy select with subscript errors. So this may be your version of tidyverse.
Okay, I might need to update.
When did you install it?
I don't know, last spring, I think.
Yeah, just update tidyverse. That should fix it.
All right, sounds good. Thank you.
Mm-hmm. The little update button right there on packages should get it for you.
Yeah.
Okay.
Thank you.
Mm-hmm. Ethan, you got a hand up. Accidental hand, I suppose. Okay.
Yeah, that was just from uploading.
Right. Gotcha. All right, what should we arrange by?
Are you able to arrange by, how would I say this, whether it's character or numeric, that sort of thing?
Well, we have to pick a column. So here's the thing. Filter wants us to find rows. Select lets us pick columns. Arrange, we have to give it a column also. So we're going to arrange this entire data set by a column. It's equivalent in essence to like highlighting a bunch of stuff in Excel and saying sort by, and then it makes you pick a column. So here we're going to basically sort by some column. So
do the
it's already
MLO.
kind of by day and year. So what'd you say?
Can we do the first MLO aerosol and put those in like ascending order in numbers wise? Would that?
Yeah. So we could do MLO aerosol CM3. And by default, it's going to be ascending order. So now we've arranged this entire subsetted data frame based on this column right here in ascending order. So that's pretty handy. Okay, Control Shift M, another pipe. What haven't we used so far? Mutate. So let's create a new column. Mutate's a fun one. It's pretty handy. So we can overwrite columns or we can create new ones. Mutate is typically for creating a new column. Here we've got MLO arrow scat1, scat2, and scat3. So let's make a new column that's the average of those three aerosol scatter things. Okay. This is a real data set I collected, and we were looking for fungi in the upper atmosphere, and this is some associated data that came with it. So this is the particulate matter that was found in that sample, and then here's 3 scatter values. It was measured 3 times. Basically looking at how dirty the air was on that particular sampling day. So we could say MLO, arrow, scat, mean. We can call this anything we want. All right, so this is how mutate works. We give it the name of a column, and then we say that is equal to, and then we give it what it's equal to. So MLO, arrow, scat, one, two, and 3. Problem. Okay, so that'll give us our sum divided by 3. Questions about that line? Mutate, we can do as many things as we want. We just put a comma, new line. So we could say year minus 5 is equal to year minus 5, comma, CM3 rounded equals round MLO aerosol CM3. We'll round that to 0 decimals. Okay. Does that make sense? The mutate? We're creating new columns. It's the same format each time. We give it a name, we say equal, and then we use our existing column names and mathematical functions or whatever it is we want to do to create that new column. Okay. We could do a non-math version here. We could say y my day equals paste 0 year m day y day. So I've just stuck together 2011, 18, and 137 together into one long number by pasting them together with no space between. All right, how do I save this as a new data frame? This crazy thing where we filtered, selected, arranged, and mutated. What would you
write down CSV?
Write to a CSV? No, I don't. I'm not ready for that yet. I want to just save it as a new object.
Would you just assign it to, like, do an arrow?
Yeah, so I could call it df2.
Yeah.
Just like right there. So df2 will be assigned as df that has been filtered for the months that are in April and May, and where the columns are numeric, and where we've arranged it based on the aerosol per centimeter cubed, and where we've added these 1, 2, 3, 4 new columns using Mutate. So if I just run that, now I've got df2. Okay. Now there's two more things I want to show you, group by and summarize in dplyr. These are going to be your friends. Only one view has been registered on the walkthrough for exam 1, but I do cover this in there, group by and summarize. So go ahead and watch that. It's like the last 5-7 minutes when I cover this. So I can say df2, Control-Shift-M, group by, okay, what are the things I've got in there? Let's group by year. And then Control-Shift-M, summarize. Summarize works kind of the same way as Mutate, where we give it the name of what will be a column, and then we tell it how to get the value for that column. So I could say mean CM3. I can call this whatever I want, equals, and then I give it a function that returns a single value, mean MLO aerosol CM3. Let me walk through this again for you. We've taken our new data frame that we made up here. We're piping it into the group by function, and we told it the name of a column to group by. So in this case, it's going to keep basically a hidden grouping variable in our data frame, okay, where year is the column that it grouped by. Then we pipe that data frame to summarize. Summarize lets us set the name of a column and tell it how to calculate the values found in there. These, in the most recent version of dplyr, these can return more than one value, but let's keep it to things that are like point values for right now. Things like sum, mean, min, max, right? So we can get the mean value of the aerosol density for each year. And here is our data frame with those results. Okay. We can just keep adding new summary columns. Min CM3. Well, that's the min function. MLO aerosol CM3. Max CM3. Well, that's the function max. MLO aerosol CM3. Number of observations. This is a special command, which is just n. Okay. So here's our nice little data frame we've got. This is summary data for our crazily mutated and subsetted data. We've gone in and we found for each year, we've got the number of observations, the mean, min, and max for aerosol density. Okay. This should look pretty readable to you. The only way you're going to get good at it, though, is by practicing. In this case, you've got your tidy data chapter, and even more than that, actually, is transforming data frames right here. This will walk you through using a built-in data set called New York City Flights 13. Okay, And it'll show you all these again, so it'll give you another chance to basically work with filtering and all that good stuff, okay, with some exercises. In addition to that, we've got the dplyr verbs and tidyr verbs, so you can look at those if you want. I've got the biolog challenge that I want you to do, and then the out of order code 1 and 2 that I want you to practice with. Okay. Assignment 7, we're going to be using tidyr, okay, and dplyr to look at Utah religions by county. Okay. So you can go ahead and get started on that. What I'm having you do is essentially take some really messy code and convert it into this piped tidyverse format, okay, and then look at things. So that's using arrange, group by, summarize, filter, select. Okay. Any questions about these 6 verbs? You're going to be using them quite a bit as you manipulate data. Okay. If you had like some trouble making that really difficult plot from, I think it was assignment 4, there's that last plot. It was a super pain in the butt.
Yes.
Yeah. Well, this is the easy button for that, right? Arranging right there by that data frame. Okay, so setting it to a factor and arranging by descending. You get your new variable by doing mutate, right? It was like the sepal length value divided by the mean, or minus the mean sepal length. Well, that's mutate, and you could have chained this all into a nice little simple thing. Now, this chain that we did here, it's just spitting out the results to our console, right? We could save that as a data frame, or Control-Shift-M. This is where it gets really crazy. We could go straight to ggplot with that. Okay. So we can plot based on this summarized output. Okay, so we could just go straight into aesthetics because the first argument to ggplot is that data frame since we piped it in. Okay. So we could say x equals year, y equals mean, CM3. Okay. Size equals n obs plus geom point. So we're looking at year and the particle density average, the mean particle density for each one of those years, and the years have been, the points have been sized based on the number of observations we had for that year. Okay. So the tricky thing here is that we've switched from a pipe to a plus. You're used to the plus in ggplot, so that shouldn't be too hard. So often when you're reading code, or even code that I type, I will do this. Like I'll do some transformations on data and then pipe it straight into ggplot. Because maybe it's a really big data set. I don't want to have to plot the whole thing. So I'll do a select, or a filter, or a range, or a mutate, and pipe that straight into ggplot. It keeps you from having to keep making new versions of each data set over and over, clogging up the memory on your computer. This is just kind of streaming through. We're taking our data set, we're grouping by year, creating our summaries, and then plotting those summaries. Okay. Got a good 10 minutes left for questions about these 6 verbs. It is well worth looking into them. Definitely do those chapters I link to. Do the example practice stuff that I've got linked in there as well. You'll see some neat little tricks. So like df select starts with M. Well, that's pretty handy. That picked all the columns that start with a capital M. Okay. So there's a bunch of little helper functions for this. There's contains, capital L. Right. There's contains arrow. So here's just the columns that have arrow in them. So this can be pretty handy. We could then say arrange by MLO aerosol CM3. Well, that's ascending order. If I wanted descending order, I could wrap that in DESC for descending. Right? These are all to be found in those walkthroughs online. Handy stuff like that. Kind of helps you get your code into easy, short little statements chained together, and so that it's readable. Who feels like perhaps by Wednesday you will have done all the practice work and will be ready to start with the next section of the class? Give a hand raise. It's about half. Okay. So we may spend a little bit more time in that case. Regardless, I do want you to have done all this practice and gone through these resources by Wednesday so that we can get rolling a bit harder and faster. Because we're going to start looking at joining tables together based on columns. And go through some examples of working with actually dirty data, and we'll just be cleaning it in real time. Okay. Then essentially we're ready to start writing our own functions. Okay. And then building models. And this is where the rubber hits the road for all this insanity you've been learning and working on and practicing and doing assignments. Okay. This is essentially where we start doing stats. Okay. But you'll have those skills to plot it. You'll have the skills to get your data cleaned up and ready to plot and ready to start modeling. Without spending time learning how to clean, you'll never be able to do stats. Okay. Because no data set comes completely ready. To do these, when we meet back up on Wednesday, I will assume that you have done them. Okay. We'll have maybe 5 minutes for questions, and then we'll get rolling. Okay. If you want to work ahead, if you're feeling comfy, then start working on week 7 stuff. And we're going to start looking at data entry, because you're going to be entering data as a scientist or dealing with people who are entering data. And so we're going to design validated Excel spreadsheets, and we're going to put together an experiment together in class. I will generate fake data for it. You're going to, however you decide to enter the data, I'll make the data fit that, and then you're going to have to analyze it. Okay. Or not analyze it yet, but clean it and get it ready for analysis. And if you're super excited, exam 2 is open. I've pushed it to GitHub. So you can start working on that if you want. That'll be due at the end of next week. All right, any last questions? You're free to go, otherwise. Practice, practice.
Cool. Thanks.
Yep.
When are you gonna declare the winner?
Hopefully by tomorrow morning we'll have a good consensus on Twitter. Cool.
Dr. Zahn, I had a couple errors pop up from the code I was copying from your screen.
Sure. If you want to share your screen, I'll take a look.
Yeah, I would, but again, this is.
Oh, yeah, paste it in. Sorry.
Yeah. That's.
So you may want to do like a Control A to highlight everything in there.
Yeah.
And then just copy your entire script.
Mm-hmm.
And
just everything.
Go over to the copy paste code.
Yeah.
And paste it in right there.
Copy paste code. Okay.
Yeah.
Yeah. Okay.
Can you also look at my code? I'll share my screen later.
Yeah. Just waiting for Carlos to get his pasted in here.
Finally there.
Okay. Okay. So here's yours.
Yeah, I don't know why my screen's got blank for some reason. Okay, there we go.
Okay. Put your pipe. All right. Clamps. That's working. All right. So was that the first error you were getting here?
Yeah.
All right. So df filter month in and select where is numeric range. Okay. Then mutate. All right. So we've got sum of those divided by 3. Here 5. So rounded to 0 decimals. Oh, you're gonna love this. Missing parentheses there. So that last parentheses closes off the mutate function. So that's why that didn't work. Okay, let's see here. Now, MLO arrow scat 1, scat 2, and scat 3 didn't work. That's because those are not actually capitalized.
Oh.
Right. So those all need to be lowercase. And now that worked. And then that works. So yeah, decapitalize the A in arrow and then close off with the parentheses, and that's all that was wrong.
Okay, thank you.
Mm-hmm. All right, and Ernie, you had something, right?
Yeah.
All right, you can share your screen.
Okay. Mine doesn't work. for the plot. So wait a minute. This works. Okay.
It must be a data frame. All right, so that works. All right, so then DF2, group by year, summarize. Okay. On line 47, you've got an extra parentheses.
Oh.
At the very end. So you had closed out your summarize function too early. Now that should work.
Is it right here that we close it?
Now line 47. See, your error says could not find function mean. The mean function is actually lowercase m, not capital.
This.
No, the on the right side of your equals. Yeah,
right
yeah,
here,
perfect.
right?
Yeah. Now that should work.
Okay.
Bingo.
Cool.
Mm-hmm.
Cool. Thanks. Those little things. Oh man.
Aren't they annoying? Yeah. They get easier, I promise.
Yeah.
I found
That's
them,
what I've known.
Like, you see me, I look at your code, and within 10 seconds, I know what's wrong. That is not a superpower I was born with, I promise. It's just from hours of making that exact same mistake myself. You start to get a feel for what the errors are telling you and what to look for. The patterns kind of show up. So it'll get faster.
And I've started to learn how to read the errors right here.
Yes.
So
yeah, that's a very important skill. Yep.
Cool. Hey,
Cool.
So should we just save this in the data course or?
Yeah, wherever you want to save it. So you could make a separate folder, like right next to data or whatever, and just call it scripts. That's actually what I did in mine, was like lesson scripts. And so then each day I can just save it as something, whatever meaningful title you want. And that way you'll have it for the future.
Cool. Thank you.
Yep.
Have a good
See
day.
ya.